Hello everyone, my name is Kira and I will be talking about plasticizers, or more specifically I'll be talking about the group orthophthalates, which are the hidden danger that lies sleeping all around us. First, let's go over some basics. What are polymers? Polymers are long chain molecules that are created when two smaller monomers react and join together. We'll use a PVC as an example to show the mechanism of the reaction. The first step of this addition polymerization mechanism is the initiation step, where a peroxide molecule spontaneously breaks in a heterolytic manner, where one electron from the bond goes to each half of the molecule, creating two radicals. The radical then forms a bond with a chloroethene molecule by breaking the chloroethene's double bond. Once again, this is done heterolytically, and another radical is formed, which begins the growth of the polymer chain. The next step in this mechanism is the propagation step, where our earlier radical will react with another chloroethene molecule to create a growing chain. This type of polymerization is also known as chain growth polymerization because monomers are added one by one to the radical end of a growing polymer chain. Finally, the last step of this mechanism is the termination step. Here, two radicals will react together to form a bond. As a result, the polymer chain loses its reactive end and so cannot grow any longer. This means the reaction has now finished and the polymer is complete. So what about plasticizers? Plasticizers are the small molecules that are used in polymers to separate their chains and weaken the interactions between them. This allows manufacturers to change the properties of their polymer. For example, brittle polymers can be made elastic. An effective plasticizer will contain both polar and non-polar functional groups. The polar groups will allow it to remain in the polymer matrix, whilst the non-polar groups will weaken the attractive forces between the polymer chains. Creating a plasticizer. The typical reaction for creating a plasticizer is alcohol plus acid equals plasticizer, and there are many different types of plasticizers that have been created. In this video, we will be focusing on the orthophthalate group. Phthalates are usually straight or branch-chained alkyl alcohols, which are formed from a C4 to C10 chain length alcohol and either phthalic anhydride or terephthalic acid. An example of a commonly used phthalate plasticizer is DEHP, or dioctyl phthalate, which is created from 2-ethylhexanol and phthalic anhydride. This plasticizer is widely used because it is good at its job and has low manufacturing costs. Now let's look at the applications of plasticizers. 90% of plasticizers are used in the production of PVC, or polyvinyl chloride, which is a multifunctional polymer that's used for insulating cables and creating synthetic leather, and many other things. Plasticizers can also be found in many common and everyday things that you might encounter, such as in ink paints, printing inks, adhesives, nail varnish, hairsprays, deodorants, perfumes, many medical equipment items such as IV bags, children's toys, in the plastic food packaging, and even in the coatings of some pills. So plasticizers can be found in pretty much everything around you. Amongst the numerous plasticizers that have been created, some can be particularly harmful to us and to the environment, so many regulatory bodies such as REACH exist to ensure that they are being used safely. The low molecular weight orthophthalates, such as DEHP, are some of the more harmful plasticizers, and so are authorized to be used, but only under extreme control. The debate. As such, there has been lots of debate over the extremely wide use of plasticizers. The big question often asked is, are they safe? The argument against the wide use of plasticizers revolves around the key idea that plasticizers can easily migrate and leach out of the polymer they are being used in, as they are in no way bonded to the polymer matrix. The most concerning area of plasticizer use is in children's toys and medical equipment that is used on pregnant mothers and newborn babies in hospitals. The plasticizers enter the children's systems through these means and have been associated with many risks and conditions. Some of the more concerning and harmful side effects brought about by plasticizers are damage to key organs, damage to the reproductive system, damage to the pulmonary central nervous system, damage to the immune system, increased chances of liver tumours, damage to the endocrine system and the hormones, bronchial obstruction, premature puberty, increased chances of testicular dysgenesis syndrome, adverse neurocognitive development, increased chances of asthma, increased chances of allergies, renal damage, insulin resistance, thyroid dysfunction, and many, many more. Now let's talk about how damage occurs to the body. The method suggested as to how plasticizers cause damage within the human body is as follows. A redox cycle is initiated, where electron transfer occurs, creating a reactive oxygen species, which is a toxic agent that leads to oxidative stress in living systems, which damages our internal organs. This process is summarized by ET-ROS-OS. Now let's talk about some research studies. During the years of heavy reliance on the orthophthalate plasticizers, many studies were carried out into the potential risks associated with their use, and many seemed to find evidence that these plasticizers were dangerous. An NTP-NCI US bioassay program ran tests on mice who had high levels of phthalates in their bodies and found that the number of liver tumours occurring greatly increased. A Swedish-Danish study in 2004 then linked DEHP to the development of allergies in children. Other studies focused on phthalate influences on the fetus and found that many of these plasticizers could even pass through the placental barrier, which led to complications in the infants upon birth, and even affected the length of the pregnancy. Further studies showed that the levels of phthalates were 12 times greater in children than in adults, due to the mass production of plasticizer-containing toys, leading to all the numerous side effects listed earlier. As a result, in 1999, the EU Commission overseeing the manufacture of plasticizers limited the number of orthophthalates, such as DEHP, that children's toys could contain to just 0.1%. So what about the environment? Of course, humans weren't the only ones affected by the wide use of plasticizers. The environment has also taken a heavy hit, as plasticizers can now be found almost anywhere and in anything, having spread to even the most remote areas of the world, like the Amazon rainforests and the Arctic Circle. They are thought to enter the environment through loss during their manufacture or leaching as the final product is volatilized, and some are known to have particularly long half-lives, such as DEHP, which has a half-life of 2,000 years in aqueous media, so in the soil, air, and water, meaning that the plasticizers won't naturally decay away anytime soon. The other side of the argument. On the other hand, the large number of seemingly unconnected studies into the effects of plasticizers has made some experts call into question the reliability of the results. There are calls for more experiments to be carried out and for tests to be repeated to determine once and for all if plasticizers are harmful. The level of risk from plasticizers must also be taken into consideration, as the risk is equal to the hazard times the exposure. Anything can be harmful to us if it's in a significantly large dose. Many argue that while plasticizers could be harmful, in the small doses that they are used in, they are pretty harmless. Other scientists take the standpoint that plasticizers shouldn't even be able to leach out of the polymer, as they are secured within the matrix and could only be removed from the product if it was experiencing very harsh external conditions or very abrasive cleaning solvents were being used on it. In 2004, a study at the Washington University even went on to conclude that plasticizers cause no adverse effects at all in adolescents. This is completely going against the studies mentioned previously. So, what about the future? As such, you can now surely see that whilst the debate seems to tend towards plasticizers being harmful, there is still a lot more work that needs to be done to truly establish cause and effect, and to consolidate all the previous findings. More research needs to be carried out to observe how plasticizers interact with other molecules, to determine if the plasticizers themselves are dangerous, or if further reaction occurs after manufacture that produces harmful compounds. There is also a need for more accurate and reliable testing to be developed in this field to reduce the chances of errors and anomalies occurring. Finally, many experts think there needs to be a drive to identify remediation techniques and to remove the plasticizers that are contaminating our environment. Currently, there is research being carried out into biotic and abiotic degradation of plasticizers through photochemical degradation and hydrolysis. However, there are others who believe that microbial degradation using aerobic and anaerobic organisms will be more effective. So, to summarize, polymers are long-chain molecules that are created when two monomers react together. Plasticizers are the small molecules that help change the properties of polymers, for example, making them more elastic. There is currently ongoing debate about the true risk that they pose to us, as some can be especially useful, whilst others can be more harmful. However, they are already all around us, so the future focus for this field is to find ways of lowering their levels in adults and children and removing them from the environment in the most effective way possible.